हेलो एवरीवन, दिस इज निहाल एंड आज हम एक नई प्लेलिस्ट स्टार्ट करेंगे जिसमें मॉडर्न अलजेब्रा के सारे PYQs ऑफ यूपीएससी सिविल सर्विस एग्जामिनेशन एंड फॉरेस्ट सर्विस एग्जामिनेशन डिस्कस करेंगे। आज हम स्टार्ट करेंगे 2023 के पेपर ऑफ सिविल सर्विस एग्जामिनेशन के ग्रुप थ्योरी क्वेश्चंस के साथ। सो फर्स्ट ए क्वेश्चन कहता है कि लेट जी बी ए ग्रुप ऑफ ऑर्डर 10, लेट जी बी ए ग्रुप ऑफ ऑर्डर 10 and let G dash be a group of order 6. Examine whether there exists a homomorphism of G onto G dash. यहाँ ध्यान देने वाली बात यह है कि यहाँ पे on to homomorphism की बात कर रहा है क्वेश्चन. So we need to find if there exists a phi homomorphism phi from G to G dash which is on to. So इस क्वेश्चन में हमारे पहले तो मैं आंसर बता देता हूँ कि देयर डज नॉट एग्जिस्ट सच होमोमॉर्फिज्म व्हिच इज ऑन टू फ्रॉम जी टू जी डैश। तीन कंसेप्ट काम आएंगे। फर्स्ट कंसेप्ट ऑफ होमोमॉर्फिज्म, सेकंड कॉची थ्योरम ऑफ ग्रुप थ्योरी, थर्ड लैग्रांजेस थ्योरम। So concept of homomorphism which says that order of image divides the order of pre-image. That means order of phi of A divides the order of A. Let us say that phi A is the image of A, then order of image divides the order of pre-image. This is the concept of homomorphism. Then Cauchy theorem. Let G be a finite group and P prime divides the order of this group, then there exists an element A such that order of A is equal to P. This means that if G is a finite group and prime P divides the order of group, then there exists an element of order P. As simple as that. And Lagrange's theorem, which says that order of a subgroup H divides the order of group. It means that order of subgroup always divide the order of group. So these three concepts will be used in this question, and at the end we will also discuss this concept, how it comes. So let us start the solution. So by method of contradiction, let us assume that there exists a onto homomorphism phi from Z to Z dash such that which is onto and homomorphism. Concept of homomorphism says that for group theory, if Z dot be a group and G star G dash star be a group and phi is a homomorphism from this to this, then for A and B two elements of G, then phi of A dot B is equal to phi of A star phi of B for all A and B belongs to Z. So method of contradiction, we say that there exists a phi homomorphism from G to G dash which is onto and homomorphism. Let us see what happens. So by order of G dash is 6 and 3 divides 6 and 3 is a prime number. Then by Cauchy theorem, there exists an element A of order 3 belongs to G dash such that order of A is equal to 3. That means G dash में एक 3 order का element है and phi on 2 है. That means there exists pre-image of A because phi is on 2. So there exists B belongs to G such that phi of B is equal to A. क्योंकि this is on to homomorphism and A belongs to Z dash, A belongs to G dash and order of A is equal to 3. Now the concept of homomorphism will be used, which says that order of image divides the order of pre-image, that is B. Or pre-image of A is B. That means order of A is 3. 3 divides order of B. What is the possibility for order of B? B belongs to Z and order of G is equal to 10, which is given. So here the concept of Lagrange's theorem will be used. A corollary of Lagrange's theorem says that order of element of a group divides the order of group. That means order of B divides order of group G. That means what is the possibility for B? It is that means order of B divides 10. Hence 1, 2, 5 and 10. These are 4 possibility for order of B. But 3 does not divide any of them. 3 divides 1, 2, 5 and 10, which is not true because 3 does not divide any of them. That means 3 does not divide order of B. That means the order of A does not divide order of B. Hence, we reached a contradiction. That means phi does not exist. Phi, that is on to homomorphism, does not exist. Now let us prove the concept of homomorphism, that order of image divides the order of pre-image. Let phi be a homomorphism from G to G dash and let A be an element of G. Then we want to show that claim क्या है? Claim is that order of phi of A, that is image, divides order of A. So how to prove that? Let us assume that order of A is equal to n. That means n is the least positive integer, least positive integer such that a to the power n is equal to identity. Now if we prove that phi of a to the power n, let us consider phi of a to the power n is equal to phi of a dot phi of a dot phi of a n times. By the concept of homomorphism, this can be written as phi of a dot a n times, which is equal to phi of a to the power n. And since order of a is n, that means a to the power n is equal to identity. Means phi of a to the power n is equal to identity, which is e dash, the identity of g dash. Hence phi of a to the power n is equal to e dash. And phi of a belongs to G dash, that is a codomain group. Now our claim is that order of phi of a divides n, that is order of a. How does it happen? Let us assume that order of phi of a is equal to t. Now by division algorithm, n is equal to q into t plus r. There exist q and r such that n can be written as n is equal to q dot t plus r, where r is between 0 and less than t. So let us write phi of a to the power n is equal to phi of a to the power q dot t plus 1 plus r, which is equal to phi of a to the power t q dot phi of a to the power r. Phi of a to the power t is equal to identity because we assume that order of phi of a is equal to t. Hence, this is equal to phi of a to the power r, and phi of a to the power n is equal to e dash we already proved. That is identity of g dash. This shows that phi of a to the power r is equal to e dash. But r is less than t, and t is the least positive integer such that phi of a to the power t is equal to e dash. But here we achieved that phi of a to the power r is equal to e dash and r is less than t. That means r is equal to 0. Hence n is equal to q dot t plus r, where r is equal to 0. That means n is equal to q dot t. Hence t divides n. T is the order of phi a and n is the order of a. That means order of phi a divides order of a. This completes the proof. If you have any doubt, you can ask in the comment section. Let us move to the second question. It is a very interesting question and a 15 marker question, which says that prove that a non-commutative group, that is non-abelian group of order 2p, where p is an odd prime, must have a subgroup of order p. This can be solved by two methods. One, using Cauchy theorem of group theory. Already discussed in the first question, which says that if G is a finite group and P a prime number divides order of G, then there exists an element A of G such that order of A is equal to P. Ultimately, it says that if G is a finite group and P divides the order of group, then there exists an element of order P, where P is a prime number. So order of group is equal to 2p and p divides 2p. That means p divides order of group. Hence there exists an element A such that order of A is equal to p. Now we can construct a subgroup by A. Identity A square, A cube till A to the power p minus 1. This is a subgroup and order of this subgroup is equal to p. Hence there exists a subgroup of order p. But it is a 15 marker question. We use the Cauchy theorem. So in the proof, we need to prove the Cauchy theorem. Second method which I will use to explain this question is very generic in organic method. So now let us solve this question by that method also. Second method. Method of contradiction. Let us assume method of contradiction. Let us assume that there does not exist any subgroup of order P. That means there does not exist any element of order P also. If an element of order P exists, then we can always construct a subgroup of order P like we have done in this part. If A is element of order P, then we constructed H, which is a subgroup of order P. If there does not exist any subgroup of order P, that means there does not exist any element of order P of group Z, and order of G is given is equal to 2P. As we discussed in the first question, Lagrange's theorem. Lagrange's theorem says that order of every subgroup divides the order of group. Let H be a subgroup of G, then order of H divides the order of group. And corollary of this is that order of every element divides the order of group for all A belongs to Z. Then Z is a group of order 2P. What is the possibility of elements of this group? By method of contradiction, we already assumed that there does not exist any element of order P, and other divisors are 1, 2, and 2P. Since we already assumed that there does not exist any element of order P, if there exists an element of order 2P, let us say A be an element of G such that order of A is equal to 2P and order of group is 2P. That means group is cyclic and cyclic groups are abelian. But in the question it is given that group is non-commutative. That means there does not exist any element of 2P also. Because if there exists an element of order 2P, then it will be cyclic and cyclic groups are abelian. But it is given that group is non-abelian. Since that means there does not exist any element of order 2P. Hence, all the non-identity elements are of order 2 because only one element which is identity is of order 1. So, for all A belongs to Z and A is not equal to identity, then order of A is equal to 2. Hence, A square is equal to identity. Since E square is also equal to identity, that means A square is equal to identity for all A belongs to Z. This is a very interesting property that order 2 elements are self-inverse. Self-inverse means if we multiply both the sides by A inverse, then A square is equal to A inverse E. A inverse A dot A is equal to A inverse identity. This will cancel out each other. A is equal to A inverse. That means A inverse is equal to A and self-inverse. A is self-inverse. This is true for all A belongs to Z. Since every element of A element is of order 2, so all the elements are self-inverse. Leave it aside. We will not use this property. Now we need to prove that we need to reach a contradiction. Let us assume another element B belongs to A and B both belongs to G and consider A B का square is equal to AB what AB, and since AB belongs to G and every element of G is of order 2, so order of AB is also 2. If AB is if A is distinct from B, then B cannot be inverse of A, so AB will not be equal to identity. So order of AB is equal to 2. That means AB ka whole square is equal to identity. Anyway, we have proved that A square is equal to A for all A belongs to G. That means AB ka whole square is equal to identity for all AB belongs to G also. So this is equal to identity. So identity is equal to AB, AB. Now multiply both side by B from the right. So identity into B is equal to AB, AB ka B dot B, which is equal to AB, AB ka square. And B square is equal to identity because B belongs to Z. So which is AB, A into E is equal to EB. It can be written as B is equal to AB, A. Now multiply both side by A from the right. So BA is equal to AB, A dot A. This becomes AB, A square, and A square is equal to identity. So AB, E, which is equal to AB. This is true for all A, comma B belongs to Z, because in general it is true for all A belongs to G, and we have taken A as arbitrary element of G, so it is true for all A B belongs to G. That means A B A is equal to A B for all A comma B belongs to G. This shows that G is an abelian group. But in the question, it is given that the group is non-commutative. Hence, we reached a contradiction to the hypothesis that there does not exist any element of order P. By method of contradiction, we assumed that there does not exist any subgroup of order P. By that, we got that there does not exist any element of order P of the group G. But to this hypothesis, we reached a contradiction from the fact given in the question. So that means there exists an element A belongs to G such that order of A is equal to P. From this element we can construct a subgroup H, which is equal to identity A square A to the power P minus 1. Order of H, we can see that it is P. Hence there exists a subgroup H such that order of H is equal to P, which is asked in the question that odd prime must have a subgroup of order P. So आज के सेशन में इतना ही ठीक है, और आगे हम इंडियन फॉरेस्ट सर्विस और सिविल सर्विस के ग्रुप थ्योरी के क्वेश्चन ईयर वाइज सॉल्व करते रहेंगे. थैंक यू गाइस. यू कैन ज्वाइन टेलीग्राम ग्रुप if you want to ask your doubts. I will be happy to solve your doubts, and also like and subscribe the channel. Thank you very much.